I think this is on. Yeah, okay. Now, I only have about an hour before work starts. I haven't worked on this all week, but I've been dying to. So I figured this morning I would try and do just a simple thing from my to-do list. Now, I haven't looked at this in over a week, so it's going to take me a while to get back into it here, but yeah, I/O components, saving and loading. Oh, yeah, this is what I want to work on next, but I don't have time to get into it this morning, which is kind of frustrating. I guess we can do the I/O components. I guess I'll put it here. I'll kind of borrow a little bit from Logisim. So I guess maybe we'll do, I don't know, something like this. And then for on, we could do something like this. Actually, I think Logisim does write 0 and 1 in it. Hold on, let me open it up here and take a look. I mean, Logisim has already solved this problem, so. I see. They have an empty. I see. They do. I don't have space to write the number here in this little square, but. What if I do something like this? That's kind of good. I don't like how it doesn't have a border though, so maybe I can do this. It's a little strange that it's the same color. Right, and I also need a way for the user to toggle it when they're using it. Actually, no. Let's just see how it looks against the white. Yeah, I mean, this is fine. You know what? I think it's fine. Am I gonna add another tool? Oh, you know what? There is something else that I thought about while I was away, which is, this is something I could do in an hour. I think this IO components, I might be able to squeeze it in, but I'll call this better tool select. The idea is to hold Z and hit an arrow key. Well, I'm thinking to myself though, because when you're in the component mode, I make it go immediately to wire mode right after. Maybe I won't do that, because then it'll be a pain if you want to place a bunch of components. But I can't expect things to be super smooth all the time, so let's just try it, see what happens. Well, I'll call this, I don't know, T menu. And we'll just always put it in the middle of the screen. I mean, this is not super efficient, but or I guess there is a section of the main loop here that is in the normal camera mode. Well, yeah, whatever. Run 1. So I guess Man. I'm having my usual, like, I can't decide on how to do it. I'm having this problem at work too, like at my job. I have to do a task and I just can't I'm in the paralysis by analysis stage. Because I'm thinking to myself, like, to do this tool menu, um, I'll have to have the same thing that I kind of do for the component menu, where I have some state variables that remember where your selection is. And I'll need to change the init function to know when the tool menu is active and move the tool menu cursor. And I'm also hesitating that this tool menu is even such a good idea. The system I have right now is fine. Maybe I could use the player one controls. Nah, let's just forget this. I'll leave it here in the list, but instead here I'll say, or anything that seems better. Yeah, let's go back to trying to do the I/O components. I really do need this. So I guess I need to add it to the component menu. Oh, we're gonna need to find another name. What the heck is this? Set metadata. Oh man, I did some really bizarre stuff here, didn't I? What? What? Oh, I get it, I get it, I get it, I get it. This is a 2D table. I get it. For drawing I/O stuff. Here's a thought. I guess there's no reason I can't do this, but should these connect to all, oh geez, connect to all four sides? Because I'm gonna make these component objects, which means they're gonna have 4 ports. And it's kind of cursed here, but that 0 and 1, I can't really do anything about it. It's because like I can't put it in the middle, is what I mean. Whatever, it's fine. So then, I mean, what other I/O components am I gonna have? It'd be nice to have like a RAM. Or like a ROM. Anyway, uh, let's think of a cute name here. Maybe I should call it something other than IO so I can give it a person's name. I mean, granted, I don't know all the different names around the world. Maybe, oh yeah, Io is the name of a planet or a moon, not a planet, I mean. Yeah, it's one of the moons of Jupiter. I don't want to just call it IO though. I think that'll be confusing for drawing, I don't know, inputs. Maybe I can't stretch this joke any further. I think it's run its course. We can call it misc. I think I'm going to need other things in the misc table anyway. I'll just have a place misc function that sorts it out. And we'll call this whoa. It's been super foggy here lately, which is kind of unusual. And the sun just rose. Well, it didn't actually just rise, but from where my apartment is, it's blocked from view by some apartment buildings. So I actually have to wait a bit after sunrise before I actually see the sun. But there's a really cool visual effect of the sun through the fog. Anyway. Now, I still can't think of a good. I mean, what if I just give it like a random name, like just like Thomas or something? Like, I'm gonna get confused. Whatever. I'm sticking with Thomas. Anyone who wants to work on this code is gonna be like, "Why did you do that?" Oh well. Then we can go in here to the drawing functions. Oh wait, did I finish that line of code? Oh, yeah. In case you can't tell, I'm listening to some music, but I got it turned off so I don't get copyright stricken. I should really just make this, you know what, n rows calls. Whatever, it's cheesy, but who cares? Whoops. Wait, what? Oh, yeah, okay. Ooh, something I did is not correct. I think these are backwards. Alright, there we go. Yeah, and now I need to go in here. Fine. I mean, it's a little cheesy here, but, you know. Well, actually... One, two, three, four, 5? No. 2, 3, 1. So what we need is G cell X of G menu lens of G cell Y. I'll fix this, don't worry. This is now n rows, this is now n calls. There we go. Yeah, that's fine. It's not expected to do anything. Okay, great. Now, man, this code is, yeah. Oh, great. Did that all in here. This is so dumb. Why did I do this? Oh, I just have this place obj function. Yeah, okay, actually. Local O equals type is going to be, I guess I'll just call it IO. C equals L, why not? T off is going to be equal to T, I guess. Oh, lookup. I don't need any lookup values. I don't need a let. And the state is going to be 0. And that's pretty much it. Now, over here in the drawing functions, I mean, I'm really glad I did this stuff here about making the gates and the registers and the junction, oh no, not the junctions, but the gates and the registers use this like common port method. Oh, but, shoot. But the IOs are not going to connect to the gates. Well, we'll cross that bridge. Let's just get this working first. So if type is net, do that. If type is gate, do that. If type is junction, do that. If type is reg, do that. And then IO then. Local Tino to the O dot T off is O dot state. And that's it. So we don't have a way to change the state yet. Oh boy, geez, okay. Look at value base. This is kind of cheesy, but like, it will work. Ooh. So something bad is going on. No, how do I get into there? Gate 1 points. The grid is wrong. Oh man. I wonder if this is because I don't understand. Oh, wait a second. Oh man, I think I know what the problem is. Because I did notice that it got overwritten with a wire. Okay, first let's just go in here and just do this for a second. Everything's fine, but for whatever reason the wire just like overwrites this, so I think the problem is actually in placing this wire. What do I have in the log? Just add to previous wire. Shouldn't that? So this should be true. P is adjacent. I know this code works, so I'm not worried about that. Now P dot is comp. That should be true. What is P? Grid of last wire Y, last wire X. Oh, I see. I never updated that when I did that is comp change. That should fix it. Yeah. Okay, great. We'll have to deal with auto-connecting to adjacent gates, but we'll do that some other time. The thing that, oh my goodness. Attempt to index field C. Oh, I see. I need to do that here too. I mean, it is nice that it's starting to clean up a bit. Okay. Okay, good. Now we need a way to change its state. You know, well, let's just, you know, this is my problem. I'm too perfectionist. Let's do something dumb for now. We can always improve it later. Maybe this is hinting to me how I should fix my problem at work, where maybe I'm being too perfectionist and that's what's keeping me from getting anything done. Well, I don't want to get into it. Actually, that's not true. I do want to get into it, but I shouldn't in this video, which is not about my job. This is about Pico 8. Anyway, I guess we'll just have another tool here called interact. First, let's see what this does. All right, now without even using interact, let's see how convenient it is to do stuff. So let's make our typical flip-flop. Yeah, mostly you're going between wire and component, and auto-changing to wire after component is fine. If I want to like erase a wire and go back to it, yeah, this is fine. This is fine. Now, yeah, where is my function? Here. Oh, shoot. We need to debounce this. Maybe we don't. No, we definitely do. Shoot. Oh, wait, no, we don't. We don't. Okay, good. I already fixed this problem. Else if... So hacky. This is not the cleanest code I've ever written, but part of this project is to teach myself to not be so, you know, perfectionist, I guess. For now, we won't make this a separate function. We will do local O equals grid of CX, CY, CX if O dot type equals IO, then we will change its state. All right. Well, this is not working. Oh, wait, should this be linear coordinates? I'll bet you, yeah, I'll bet you that's the problem here. Nope. All right, what's going on here? It is supposed to be linear coordinates. So if I hit X, it's not logging anything. What's going on here? Oh, duh. I don't think I need this. This should do nothing. Now if I put one of these down and interact, hey, not too bad. Okay, great. Let's draw our usual stuff. I don't know, let's do the flip-flop, why not? But this time, we can use this, which is a nice change, to test it out. I mean, we've got other problems with this because they don't connect automatically, but actually, let's just see if they randomly do. No, they don't. Can I connect them? No, I can't even connect them. Oh, I can't connect anything. Wait, what? What's going on here? Oh, that's why. Okay, well, I can fix two problems in one shot. It's a little annoying, but whatever. It's just a limitation. And okay, so now, if I toggle this, nothing happens. If I leave this at 0 and hit the clock, nothing happens. If I change this and then have a rising edge, nothing happens. I think my gates might be backwards. So it seems to be falling edge sensitive. Maybe it was right the first time. Okay. Yeah, there we go. We finally made a flip-flop. Yeah, okay. Well, you know, let's save this. I think I gotta go to work. What time is it? Actually, I still have another 10 minutes. What's something we can do in 10 minutes? Okay, I have a little idea here. Now, the reason we use flip-flops in the real world is because latches are sensitive to glitches, they ruin timing, The timing is just stricter for latches. Wait, hold on, let me think about that for a second. The flip-flop has a certain setup time. Hold on, I'm actually trying to think of this carefully in my head. When you have a latch, my brain like autofilled, oh, the problem is glitches, but actually I need to think about that more carefully to actually understand where the glitches come up when you use latches. Because if you're using a stable clock that doesn't have glitches, then it's fine. The real issue with latches comes when the enable signal can have glitches. Like if the enable signal isn't driven from a clock tree and instead it's driven from just some combo logic that could, you know, go crazy before it's actually settled on a value. But that's not the case here, where I'm planning to use a stable clock for the latch. The other issue is with timing. This is just a real world thing. I don't even think this applies to my simulator game here, but normally you have setup time for a flop and also hold time. When you have a latch, I see. It means that your hold time, yeah, I see. Your hold time is basically half the cycle, which is a little hard to work with. Yeah, but that's not really an issue for me necessarily in this, you know, idealized game here. So yeah, let's just see if we can make a counter using latches, which is not something I've ever done before. It is nice to have these inputs that I can work with now. So first, let's try something like this. Yeah, I see. Slow down. So this is going to be my clock. This is going to be my count input over here. So I need here is an XOR gate. Oh, jeez. I know one of these is an XOR gate, but don't ask me which. Wait a minute. No, none of these is an XOR gate. Shoot. I gotta make a whole XOR gate, don't I? Well, there's nothing to be done about it. Like, that's what we have to do, I guess. We only need one. Or do we? This is pretty tricky. I was just going to do like a ripple carry counter. You know, why not? But actually, the ripple carry counter is only simple because it uses rising edge sensitive T flip-flops. Well, maybe that's what we need to do. Or we could do a... we don't need a full adder. We can get away with... I mean, it's going to have a huge... like combo latency, but we can get away with, I really need to think about this. So let's say that this bottom input is the current count value and this top input is the carry from the previous digit. Then we need to output the carry for the next digit and the sum for the next digit. So the sum is the XOR and the carry is the AND. Now, an AND we can do with one gate. If we're really clever, we could do something like, so here we have take the NOR of both of these. Then take the AND of both of them. And then take the NOR of that. Does that work? Jeez. Yeah, this is not like super easy. So now what I need is, so okay, the top input I guess is going to be, I know, the bottom output here is the carry, and this top input here will be the sum. So I think I need another NOR here. I think this works. So 1 plus 0 is 1. So the MSB here is on the bottom. 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1 is 2. Yeah, not bad. Not bad if I do say so myself. And the nice thing here is that the carry out only has a latency of 1, which means that we can do a little better. We can shrink this a little bit, which we would want to do if we wanted to have a big counter. Oh, I just thought of something. There is no difference between a latch and a flop if the clock pulse isn't like a nice 50% square wave, and if instead the clock pulse is really, really, really short. In other words, for me, 1 sim tick. So actually, let me just quickly, whoops. Let me just quickly draw myself up a little pulse clock here. We'll slow it down a little bit. And now what we need is this. We do that. Oh no, actually we do need to do this. And then here we take this and not that, or something akin to that. Like, it doesn't really matter that much. Oops. So I don't know. I think I could pick almost anything here. Like, a bunch of different gates would work for this. But the one I'm thinking of is this one. No, that doesn't work. Maybe there aren't a whole bunch of different gates that work for this. I don't know, I'm just guessing now. Oh, hey, that works. How do I do this? So here we pulse for a single cycle. Yeah, so this is a pulse clock here, which is good, which is what I wanted. Now we can come up here and what time is it? Oh shoot, I'm out of time. I'll have to do this later. Too bad. Too bad.